All right, today we're diving into one of the biggest, but kind of hidden, problems in AI. It's memory. We're going to look at this really cool new idea called nested learning. And honestly, it might just be the key to teaching an AI how to actually remember. Think about this for a second. It's a weird paradox, right? You've got these super powerful AI models. They basically read the entire internet, they can write code, make art, you name it. But then you try to teach it one new simple thing, and poof, it forgets what it already knew. How does that even happen? So, that right there, that gets us to the heart of the problem. AI has a serious memory issue. It's this massive challenge, and researchers even have a name for it. And believe me, it's a huge roadblock on the way to creating AI that can actually adapt and learn like we do. And that name? It's catastrophic forgetting. And yeah, it is just as bad as it sounds. See, when an AI learns something new, it updates its internal wiring. The problem is that update can just completely wipe out the stuff it learned before. Imagine paving a new road right on top of an old one. The old road? It's just gone. That's what's happening inside the AI. And this is so different from how our brains work, right? Our brains are the gold standard here. We have this amazing thing called neuroplasticity, which means our brains are always rewiring themselves, learning new things without just erasing the old stuff. But current AI, it's static. Its knowledge is frozen. If you wanted to learn something new without forgetting, you pretty much have to retrain the whole thing from the ground up. The researchers behind this whole idea, nested learning, they have a really powerful way of describing this. They say it's like the AI has anterograde amnesia. That's the condition where someone can't form any new memories. So for the AI, it means its knowledge is basically trapped in the past, stuck with whatever it was trained on, or maybe just what you've said in the last few minutes. Okay, so why does this happen? Why does AI have this amnesia? Well, to get to the solution, we first have to understand the root of the problem, and it all comes down to how we've always built these things, basically in two separate pieces that don't talk to each other. So you have these two parts. On one hand, you've got the architecture. That's like the blueprint of the model, its basic structure. And on the other hand, you have optimization. That's the rule it follows to learn new things. And for decades, we've treated them as totally separate. You build the blueprint, then you figure out how to teach it. And it turns out, that exact separation, that's the crack where catastrophic forgetting slips in. And this is where nested learning just flips the script. It comes in with this radical idea and asks, hey, what if those two things, what if they're not separate at all? What if we could build a single, unified system that finally closes that gap? And here it is, the big insight, the aha moment. Nested learning says that architecture and optimization are basically the same thing. They're just operating at different speeds. Think of it like a single learning system, but with different levels, a fast lane and a slow lane. And that simple idea, well, it changes absolutely everything. So instead of having just one learning speed for everything, nested learning creates this whole system with different gears. You've got these super fast updates for short-term stuff, like the conversation we're having right now. Then you have medium speed updates for learning a new skill. And finally, you have these really slow, careful updates that change the model's deep core knowledge. Doesn't that sound a lot more like how we learn? And this whole idea leads to some really cool applications, like something called the Continuum Memory System, or CMS for short. With CMS, you don't just have short-term and long-term memory. No, you get a whole spectrum, a whole range of memory modules, and each one updates at a different rate. This creates a system that's so much more flexible and powerful for learning over the long haul, without that dreaded forgetting. Okay, so this all sounds great in theory, right? But does it actually work? Can you build something with this? Well, the researchers decided to put their money where their mouth is and built a brand new type of AI to test it. And here it is. Say hello to Hope. This is the actual model they built to prove their point. It's a self-modifying AI built from scratch on these nested learning ideas. Get this, Hope can actually change its own structure, optimize its own memory. It's wild. So, how did Hope do? Let's look at the tests. First up, language modeling. They use this metric called perplexity, and all you need to know is that lower is better. It means the model is less confused. And as you can see, Hope's score is the lowest of the bunch, beating out other big models. All right, but what about something harder, like common sense reasoning? This is a tough one. And look at that. Hope comes out on top again with the highest accuracy. So this tells us it's not just good at predicting the next word. It's actually better at understanding things. Okay, but here's the million-dollar question. All that's impressive, for sure. But does it solve the actual memory problem we started with? To figure that out, they threw the ultimate memory challenge at it, the needle in a haystack test. This is where you hide one tiny fact in a gigantic pile of text and ask the AI to find it. And the results, honestly, they're fantastic. On these super hard, long text tests, Hope was way better at finding that needle in the haystack than the other models. This is the proof right here. That continuum memory system, it actually works. It lets the model find and remember specific details much, much better. So what does all this mean? Look, this isn't just a small step forward. This is hinting at a really fundamental shift in how we even think about building AI and what these systems could become in the future. So let's break down the big takeaways here. First, nested learning brings architecture and training together into one unified thing. Second, it really opens the door to AIs that can learn continuously, no more catastrophic forgetting. Third, it lets us build self-modifying models like Hope. And maybe the most exciting part, it helps close that huge gap between today's rigid AIs and the incredible flexible learning power of the human brain. And, the researchers who wrote the paper put it perfectly. They said this offers a robust foundation for closing that gap between the forgetful AIs we have now and the continual learning abilities of our own brains. We're talking about moving closer to machines that don't just spit back information, but actually learn and grow. Which kind of leaves us with one last huge question to chew on, doesn't it? If we can finally actually do this, if we can create an AI that learns without forgetting, what's the very first, most important thing we should teach it? Definitely something to think about. Thanks for tuning in.